Hello, you are welcome back to day 3 Quiver Analytics, Data Science, Machine Learning. All right, so today we want to focus on machine learning to display a practical scenario centered on machine learning. All right, so we go again, overview. We'll be using Python and look at what machine learning is. This is Quiver Analytics. You're welcome again, and we are experts in data science, business intelligence, machine learning, scientific programming, scientific data analytics, training and consulting, corporates, and as you can see, we've done a lot of extensive work with private and public institutions across the world, in Nigeria, in Africa, and beyond. And that is me, Timothy, the founder of Quiver Analytics, and a trained statistician. I I have been doing this for over a decade, research and analytics and training and consulting for over a decade, and I'll be facilitating this course. Our mission and vision, if you are new, you can read it up. If you are not, we already have gone through this. Our mission is to simplify data science, inspire innovation, and equip learners with the skills to make evidence-based decisions that transform their organization and career. Right? So, just like the results showed, we have alumni everywhere in the world, in all corners of the world. And our vision is we are dedicated to building Africa's next generation of data scientists through hands-on industry relevant training. We have actually gone beyond this vision. Of course, we are in Africa, so we focus on Africans, but we have done a lot of things for people that are non-Africans as well. All right, so let's go straight into the business of the day. Machine learning is a branch of artificial intelligence that enables computers to learn from data and improve their performance without explicit programming. It is used to detect patterns, make predictions, and automate decision making across fields such as finance, health, and marketing, and sciences, every field. All right, so the relevance is highly relevant today. As you can see, we've established that it is a part of artificial intelligence, and AI is something we all use today. So you can imagine how large the business is, you know. Um, all right. So, uh, for job details, a machine learning someone who does machine learning roles is called a machine learning engineer. He designs, builds, and deploys machine learning models and algorithms that enable systems to learn from data and make intelligent predictions or decisions. All right. Then average salary, the machine learning is very relevant and it is also very rewarding. All right. So globally, the average is about 189,000 per year in US dollars, and in the US, it's ranged between 145 to almost 250, and in the UK, it's about 75 on the average. And in Nigeria, it's about 3.5 to 6 million naira on the average. That's per annum salary. So at Quiver Analytics, we also provide you three forms of learning. One from our YouTube, which you see the channel. Just go to YouTube and search Quiver Analytics. You get our free trainings there, and then we have the self-paced course, which we have pre-recorded videos just like this, and you can learn it by yourself at your own time. We have assessments um, and projects for you to do there, and you get your certificate as well. However, for something as um, sensitive as machine learning, as complex as machine learning, would encourage you to go for the instructor-led program if you don't want to be discouraged and if you are really serious about it. All right, so we don't just teach you, we don't just train you, we provide customized assessment for you to guide you. And we also assist in your landing a job. We can also help you with your first 3 months thereabouts in your new job to get you well positioned. All right, so machine learning tools, we have Python, that's a price for the self-paced and the instructor-led. And we have R, we have Azure ML Studio. All right, so now the data we'll be working on today is the house prediction data, and it was gotten from Kaggle. And this is brief about the data. And then in machine learning, we can categorize. So some the things we'll be doing today, we'll be doing data preparation, that's a definition there, model training, model evaluation, and we'll be predicting, and a very basic form. It is not deployment, but something close to it, very, very basic. All right. So 3 steps of machine learning: data preparation, it takes a lot. Then we have data cleaning, data wrangling, data transformation, and different things. Then model training also is a lot, is a statistical part of it, to identify the model, test different models, and then to know which model performs best to get the results. The model evaluation, this is where things like accuracy and all of them comes in. Then the prediction. All right. So thank you for watching. Thank you for coming again today, which is the 3rd day of our training. So we go straight into Python. All right. So now, because you might not, if you don't have Jupyter or Anaconda installed on your system, you will not be able to open this. However, I'm going to make this available in PDF form, and day 3 you will be getting all of this. You have the day 3 presentation, the housing data sets, and the Python. Then you also have the PDF, the codes PDF. All right. So for those who don't have it installed, you will not be able to open this. All right. So what we'll do today is to do data imports and quick exploration, converting price to 1,000, and visualize data, training and evaluating a linear regression model, and making predictions with new data. All right. So now in Python, like I said, this is not really a training, but I'm sure you get 1 or 2 things. It's a demonstration, not a training. All right. So we have libraries and data sets. All right. So libraries are like additional formulas that do not come by default with your software, let me call it that way. So you have to install them and import them. All right. So because I have a lot of them already, I'm just going to import the basic ones, which are usually used for machine learning. So libraries imported successfully. Then the next thing is to load my data sets. My data set is in my repository. Repository is the same place, the same folder where I have the Python scripts. You can see ML prediction model. All right. This is the name of my script, ML prediction model. So I just print it, pd.read_csv. So I import the data, and this code, this line here, data.head, shows the first 5 rows. Now you notice that Python starts counting from 0, starts indexing from 0. All right. Then it counts 0, 1, 2, 3, 4. So 4 means the 5th one. All right. So we inspect the data by running this code, data.info. It tells us what it knows about the data. Then the isNA tells us how many missing data can be found, missing values can be found. Then the describe shows us some summary statistics. All right. So let's see. So from the first one, data information, it's a Pandas for data, and it has 1,000 entries. That's from 0 to 999. Remember what I said about starting from 0. So now the columns we have 8 columns from 0 to 7 columns. Then house price is our target variable. That's a dependent variable. All right. So you can see they are all values. All right. Then missing values, you can see 0, 0, 0. There are no missing values, so we are good to go. It is not usually all like this, but because of the demonstration process, I had to find a data set that has no missing value, no need for cleaning. All right, so these are the summary, the counts, that's how many are there. You can see 1,000 entries, each one of them. The average square footage of every, I mean, all of the entries, the standard deviation, the minimum, the 25 percentile, 50th percentile, 75 percentile, and the maximum. So we want to convert the price to thousands and make it 2 decimal places. All right, so this is the code that we are using. You can see house price divided by 1000, then round to 2. So you can see, so now we have 262, and definitely this means 262,000, not just 262, because we have converted it, we divided by 1000. All right, so let's visualize our data, see what we have. We'll be using a box plot to check the distribution for house prices. Box plot, because it is a numerical variable. Further explanation on that in our courses on visualization. And correlation heat map to check the relationship between all of the variables, because they are all numeric. So here we can do that. Then price versus each numeric variable using scatter plots. All right, so this is a box plot. I turned it horizontal. All right, and this is the correlation heat map. All right, so the correlation heat map, you can see the key here, the legend here, or the key here. Red is 1, the darkest red is 1, while the darkest blue is 0. 0 means no correlation, 1 means perfect correlation. So 0.99 here, or the leading diagonal here, they are all 1 because they are correlation between house price. You can see correlation between house price and house price. That's where they intercept. This house price, if it comes this way, then this house price, it comes this way. So they intercept here. That's why it is 1. That means we're talking about the same thing. That's why the leading diagonals are all 1, because square footage and square footage, the correlation is 1. So we really don't talk about these leading diagonals to be, I mean, we don't interpret it, all right, because it is correlation of the same thing. However, we have something close to 1, 0.99. That's the square footage and the house price. So that means the higher the square footage, the higher the price, which is basic, right? So looking at the scatter plot, you can see it's very, very linear. So we know what to expect. Then for every other, they are almost evenly distributed, because you can see for number of bedrooms, we have 1 bedroom house that is less than 200,000, and that is also over 1 million. Evenly distributed, we have them for each of them. This one is not evenly distributed, it is scattered. All right, scattered, evenly distributed across all the categories, because they are categorical variables actually. So now the next thing we do is to split the data. In machine learning, what machine learning is about is, most times we split the data either using the formula 75-25, 80-20. I mean, either we use 75-25 or 80-20 rule. All right, here we'll be using the 80-20 rule. Remember, we have 1000 entries, so 80% is going to be 800, while 20% is going to be 200 entries. So the 800 entries is going to be a training set. We are going to train the 800 entries, and then we use the 20%, that's the 200 entries, to test it. We'll test that model that we trained to see if it actually works. We'll check the actual value against the predicted value and see if it actually works. All right, so train test split, to split it, we run this. So you can see training set is 800, still 7 columns. Testing set is 200, still 7 columns. All right, so now we are going to train the linear regression, and we'll be using the training set. So you can see model equals linear regression, model.fit, we are fitting the model here. We can see X train and Y train. So we are using the train set to train the model here. All right, so we bring the coefficients out, and these are the coefficients. The square foot meter has 0.20, blah blah blah. I can say a lot about this, but again, this is demonstration, and not training, just for you to see how it works in real life. Now that we have trained the model, we have a model called model. We have fitted the model with our data, and the computer has learned, given the distribution of this data, how they relate with each other. All right. So now that we have done that, we need to evaluate the model performance. I'll be using three estimates: the R squared, the average mean error, and the root of the mean squared error. That's root mean squared error. All right. So the RMS is the most powerful of them. The more your RMS score tends to 0, the better your model is. All right, just know that as a rule of thumb. While for R square, the more it tends to 1 or 100%, the better your model is. All right, so model evaluation, we do all the parameter fitting, and then we run it. We have R square score 0.998, which is good. Then the mean average mean error, then the square of the mean error, then the root mean square of the mean error. So now it gave us the average errors in thousands. So now, like I said, I'm going to looking at the R square. It is good. R square means that 99.8% of the model or of house price is predicted using all those other variables. They are responsible for 99.8% of the variation in house price, and that is why we can have a linear, you can see actual versus predicted. So most times the actual and predicted, they follow each other. They follow each other. They are always colliding. They are always colliding. They are always colliding. That means the predicted is always meeting the actual. If it does not meet it, it just miss it only few distance, very few distance. So now remember, our data set is in hundreds of thousands. Yeah. So now we are saying that our root mean square error is, if we would have error in terms of money, it would be 10,000 naira, around 10,000 naira. What this means is, if an actual house is 100,000 and we use the this model to predict, we don't know if we have a house that is worth 100,000 given the historical data. So, but we don't know the price of the house. If we put in the features of the house, such as the foot square meter, the year the house was built, the number of bedrooms, the number of bedrooms, number of several things, and we predict it using this model. This model is telling us that, give or take, we would only have a difference of 10,000 naira. If we don't hit it, if it does not predict 100,000, it will either predict 110,000 or 90,000. All right. So it depends on you and the your clients or the organization. If 10,000 naira is allowable error for them, fine. If not, then you have to work on your model or use another model to see which model gives you a better error value. All right. So now that we have tested the prediction, and we've seen that this model actually predicts well. So now I want to predict we'll do two types of prediction. We want to predict using the average value, since they are all values. So we want to predict using the average value. So on the average, we know that the houses cost like 618,000 naira. All right. So now the part for deployments is, like I said, something very little. It is not deployment at all. This is not deployment. It's just something interactive that a common user, if you work on this, a common user will be able to interact with it, with the model. All right. So here, if I run this, you see what happens. It tells me enter the square footage. Like, we have a new house, we don't know what price to call that house. So now the deployments we have done, or the web app, or the websites, or the app that we have done, we are asking the user to enter the square footage of the house. So that's, I'm just using an hypothetical value now. So you press enter, it asks again, enter the bedrooms, number of bedrooms, let's say 3, enter. Enter bedrooms 2, is asking for year the house was built. Let's say it was built 1992, and then the lot size, let's say 2.7866, and garage size, how many garages does the house have, and enter neighborhood quality from on a scale of 1 to 10. Let's say 8. So now that I've entered all the needed parameters, you can see there are 6 parameters: 1, 2, 3, 4, 5, 6, 7. Okay, 7 parameters, and enter. So you see my prediction is 618.88 thousand. So it's predicted that a house like this should worth 618,000 naira, 88 kobo, or no, 618, yeah, around 618,880 naira. Yes, so that's what is predicting such a house should cost. So by the time you load yours and do, you can always play around some other numbers. All right, so recap what we did. We explored and visualized a numerical housing dataset, scaled price values to thousands, trained and evaluated linear regression, predicted a new house price. All right, so that should be all for the display. Don't forget to follow us on YouTube and all of the other social medias for more exciting offers. This was done to honor the World Statistics Day. And do not forget that we have trainings. Our trainings are extensive. They are extensive. The normal prices are more than this, but this is just a price that we are offering till November 15. There are a lot of things that we have skipped during this demonstration in our trainings, our thorough trainings. You would get to know everything. We build people to become experts so that you can get the desired jobs that really offer this kind of monies. Because one of the problems we have in the data science field is that we have a lot of half-cooked, in fact less than half-cooked people calling themselves professionals. They get on the job, and 2-3 months into the job, sometimes if they are lucky 1 year into the job, they have to quit because they cannot cope with it. All right, so if you train with us, that won't be your case, and we are certain that you would do bigger exploits and would do much work together. All right, so thank you, and don't forget to email us quiveranalytics@gmail.com. It's quiveranalytics@gmail.com. We also have it there. You can always reply. You get your documents as emails from us, and you can always reply us through the email. Thank you, and see you soon.